Hello, and thanks for joining me on the ClearBlade technical blog series. My name's Aaron Allsbrook, and today we're going to look at how we go about detecting anomalies in our IoT solutions. As enterprises adopt IoT, value comes not only from knowing the status of what's going on with our machines and devices, but it also comes from being able to react and resolve important events. For many of those use cases, the ability to simply watch if things are not normal provides an enormous opportunity. In this video, we're going to start by adding the anomaly detection capability to one of our IoT solutions. As is typical, we're going to start with the IPM, IoT Package Manager, and we're going to look at the anomaly detection template package. In here, we're going to click the URL and then quickly just install this as a new system. So we'll do the standard IoT Package Manager install process. We'll choose to bring in all of the assets, and when that completes, we see that we have a new system, an IoT solution sitting here encapsulated for us to begin to work with. The system's actually ready out of the box, so we could open it up and look at it, but I am going to configure a few constants just so we can do the fun stuff of seeing text messages actually alerting us. So I'll edit the anomaly detection constants library, and we'll fill in a few attributes together. With all the values filled in, we'll click Save. And now we're ready to begin actually working and demonstrating this capability. I'll click Portals and open our Anomaly Detection portal. So what this system does is it actually generates some artificial data for us to begin to working with and understanding. You can see we have a sensor feed here in the bottom middle pane sending us temperatures. These are temperatures with an expected range of variance over time. But certainly the temperatures could exceed or go below something that we expected, so it would be anomalic behavior. That same temperature feed is graphed here as the blue lines. We can see that new data begin to come in. We have kind of a timer pulling it in over time currently. And you can see that sometimes the values do go out of what we see as our red bands, this strictness of what is the anomaly. The underlying library is doing lots of math to help us set this level of strictness. But we can configure it even from this user interface by making it more moderate. So having a little more tolerance for what could be outside or even go low, and some of the things that might have been firing events before are now no longer outside of the range we're interested in. This detection rules area also lets us change which sensor we might be watching, so we could change that, and the attribute that we are actually getting off of that sensor. So if we wanted to look at something other than temperature, say humidity or vibrations, we could certainly do that instead. I'll set the strictness back to high so that we get lots of alerts here for us to look at. What you'll notice is the bands of strictness are being recalculated each time to basically better match the average temperature values that we're actually seeing. We also have an alert section here on the bottom left, so this is where we're actually calculating the times where we violated that strictness and we do have the anomaly. So we have a printout of all of that, but ultimately we want to drive that information back to ourselves and begin to see that in some sort of SMS. So I'll turn on SMS alerts, and I will provide a phone number, and I'll save that change. So now, as these alerts are fired each time, we'll begin to get SMS text alerts on our phone environment. With that done, let's go back and take a look at how we actually could configure this in our own IoT solutions. I'll quickly move back to our developer console and go look at the code services. There's really two libraries that are doing a lot of the work here. The first is our statistics library. This provides a number of statistics capabilities and mathematical work for us. But then our anomaly detection library is actually going to use that mathematical capability to define and ultimately trigger and alert around what's happening to show us what those anomaly values are. The easiest way to see how to use that is to look at the example detect anomaly service. If we look at that, we can see where we're actually defining that strictness. We're actually giving those numerical values. You can alter that for your use case. We then give it sample data, so this will be the data coming off of your sensors, and then we actually run the detection. I'll save and test this, and we can see in this data set, based upon the strictness that we have defined here, there were 3 points that actually that were anomalies that should be alerted around. Very simple to actually embed this logic into whatever business and data streams you may have. That's it for today. Thanks for joining me on the ClearBlade Technical Blog Series and talking anomaly detection.